Hello, I'm Christina and I'm a scientist at NCAR. And I'll be talking today about one of the projects I work on. There's several projects that I work on, but this project is focused on improving the prediction of severe thunderstorms. But when we're talking more severe thunderstorms, we're talking about these additional hazards that could be flooding rain, which I don't have a picture of up here, but also tornadoes or strong winds, not directly associated with a tornado, or even hail. And, one of the things with these events is you don't really want to be outside when these events are happening. So here's a video of a hailstorm that I took from my office this was in June of 2019, and it almost looks like snow, but it's actually hail. So you can hear the noise that hail is making. This is a case where you wouldn't really want to be outside. You might get injured. And so we give people alerts to take cover for storms, for these severe thunderstorms, using generally either watches or warnings. So how do we get a watch or a warning to come out? And generally what happens is you start from a model or an observation of what's happening in the atmosphere currently. And a forecaster at a place like the National Weather Service or the Storm Prediction Center takes that information, and then they produce a watch or a warning. So does everybody know what a watch and a warning is? If you don't, you can enter in the chat that you'd like to know what a watch and a warning is. A watch means that the conditions in your area are favorable for a severe thunderstorm or a tornado or whatever the watch is issued for. Whereas a warning means that that event is actually happening and it's time to take shelter. And so if we can improve the forecasts of severe thunderstorms, we might be able to give people more lead time so that they can take shelter. Now, I don't put out watches and warnings myself, but I work on this model data back in here and improving that model data so we can hopefully have better forecasts. So there's a project I've been part of for the last 3 years called the Hazardous Weather Testbed Spring Forecasting Experiment. And this past year it ran from 5 weeks, April 27th to May 29th. Now it takes place at the National Weather Center in Norman, Oklahoma, which I have some pictures of here. And the purpose of this experiment is to get a whole bunch of different types of scientists together to test our models and see what works and doesn't. So this is a case where I get to interact directly with forecasters and the people who use our models, and with other scientists who are producing different kinds of models, and we can all get together and discuss what worked and what didn't. And so here's an example of what it looks like during the Hazardous Weather Testbed Spring Forecasting Experiment. This room is generally pretty empty on a daily basis, but you can see there's a lot of people who come for the spring forecasting experiment. So what do we do during this experiment? Well, in the morning, we make out forecasts. So we use models and the products that people bring, and we create these forecasts at the bottom where we're focusing on forecasting specific hazards. So you can see on the left, I have a forecast for hail, and on the right, I have a forecast for wind. And these look like a lot of just squiggly lines, but what they are is regions where we think there's a higher probability of these events happening. So the more lines equal, the more likely we think it is to happen. And then in the afternoon is all about evaluating these forecasts. So we evaluate the specific hazard forecasts that I spoke about on the previous slide, and we do that in this case using the image at the top, where we overlay the storm reports with how likely the event is, and we see how well they match up. We also have surveys where we can evaluate the output from models, so not data that we specifically drew or created, but how well each model is performing in comparison to one another. And then we get together and we talk about what worked and what didn't. And so I have here on this next slide an opportunity for all of you to try analyzing the output of the forecast yourself. And so what I'm showing here at the top is what actually happened, and it's showing a precipitation forecast. And then the bottom is output from 3 different models and what they thought would happen in terms of a precipitation forecast. And so one of the most basic questions in analyzing how well a forecast performed is, well, which one looks the most like the top? So you can enter in the chat box which one you think performed the best, number 1, number 2, or number 3. So it's precipitation like you would see on a radar, where the stronger or the darker colors, so like the reds and the yellows, mean stronger precipitation, and the blues and the greens are lighter areas of precipitation. Yeah, so this is like a giant region of thunderstorms. I mean, I guess it's not really giant, but it's the thunderstorms are kind of where you see the reds and the yellows, and then the green is just going to be rain kind of on the outer edge of the thunderstorm. So what gets put into the model is the conditions that the model starts with, so the initial atmosphere, temperature, and then there's a number of different mathematical equations that calculate what they think will happen and where they think the storms will end up forming, and it comes together to get this output. And so then another question we can ask when we're trying to think about improving our models is, well, why didn't we pick numbers 2 and 3? What about them wasn't as good as number 1? And in this case, you might say, well, okay, the area of precipitation is just too big in number 2. It's much bigger than what we saw, and it's over Texas, whereas the actual storm was partly in Oklahoma and partly in Texas. And so we can take this feedback and this analysis that we get on what worked and what didn't, and we can go in and try to improve our model forecasts using this information, or improve which models that we use. So that was a little example of kind of what we do during the HWT spring experiment. So my work in lightning, my master's thesis was on cloud to ground lightning polarity, so what type of strike it is, and if there was any, and looking at the relationship to various different environmental conditions. Some of my other research in lightning is, I had a project, I'm not current, that project has finished, but we were looking at how to represent the feedback from thunderstorms into a model. So we were trying to represent in our model the upward current from a thunderstorm and how it went into the global electric circuit. So that was probably my most recent lightning specific project. That's a good question, because I don't know if the archived lightning data that I have is available to the public, or if I can just get it as a part of NCAR. So generally, the lightning archives either come from the WeatherBug or the National Lightning Detection Network. But like I said, I don't know what they have up there that's available specifically to the public. But if you search either WeatherBug or the National Lightning Detection Network, you'd be able to see what you can get on the webpage. So that will get recorded in our surveys, and it impacts, in some case, what models the team will select to weight heavily when we're drawing our hazards predictions, and it also will impact what models come back the next year. So if like a model is consistently underperforming, they might not bring it back, or they might wait until they've made changes to that model before trying it again. So if that makes sense. So I have not worked with the International Center for Lightning Research, and so I don't unfortunately know anything about whether their work is being continued or what their status is, because I'm not, I've never been affiliated with them. So in research, generally, yes, but the unique thing about the testbed is that we pull way more models than you're usually working with together at one, you know, in one place and at one time. So normally when I'm testing models, I might have, you know, 5 or 6 that I'm looking at, and that's a pretty large number example. But during the spring experiment, there's like, you know, 20 or 30 that we're all looking at together. And then the other unique thing is that, you know, the people who are behind those products are all together, so we can get feedback and discussions directly. So that's what's different about it.